There's a technical note that we have to make in these slides when we're doing a line integral. So for instance, if you want to get integration from 1 to 2 of E dot dr, which means you have a path that goes from 1 to 2, and you evaluate the vector, the electric field vector, at each path for each element of length, and you have the element of length vectors, and this is the way to write it as a limit of sums. So in this case, when you're going from 1 to 2, the elements of length point from 1 to 2. So the delta r's, they point from going from 1 to 2. And you expect then for these particular vectors in the problem, because here the angle is less than 90 degrees for all the elements of length between the electric field and the elements of length. So you expect the answer will be positive because you're getting the dot product here, it's a positive number, and here it's a positive number, and here it's a positive number. For these particular vectors, we expect the line integral to be positive. What if you want to integrate E dot dr from 2 to 1? Would this be positive or negative? Well, when you write it as a limit of sums, the elements of length now point from 2 to 1. So now the angle between these two vectors gives you a negative sign for the dot product. And so you get a negative number, a negative number, negative number, negative number. When you add all those, you get a negative number. So expect that this line integral will be a negative number. So it's clear here when we reverse the delta r's and make delta r go from 2 to 1, that's how we can get the negative sign when we write it as a limit of sums. But what would you do if you write it as an integral? Would you keep this dr the same as it is, or would you write it as minus dr? And this is something that's kind of a issue we just want to deal with to get it over with. So let's give a tiny example, a simple example. Let's say you have a constant electric field pointing to the right, and I want to integrate E dot dr from 1 to 2. So before we solve the problem, do you expect this to be positive or negative? We expect it to be positive because the elements of length are in the same direction as the electric field. The angle is 0, so when you get the dot product of this delta r with E, or this one with E, or this one with E, you get positive numbers. And this integral basically adds all these positive numbers, of course, when the number of elements goes to infinity. So you get a positive number. Okay, so let's do the integration. So if you put dr to be dxi, the element of length here, we're only along the x direction, so put dr to be dxi. Now I dot I is 1, so you get integration of e dx. E in this problem is constant, so it can go outside of the integration. Integration from 1 to 2 dx is x2 minus x1, the upper limit minus the lower limit. So you get x2 minus x1 is a positive number, because it's the coordinate of this point minus the coordinate of this point, which gives you a positive number, which means it's just the length d. Okay, so what if you want to integrate from 2 to 1? Now if you integrate from 2 to 1, I know that the elements of length delta r are opposite the electric field, and so we expect the answer to be negative. So where is this negative sign going to come from if you write this as an integral in this way? I'm going to tell you that let's keep this dxi exactly the same as we did before. Don't put a minus sign here to write it as minus dxi, because dx itself is negative. And the issue, the reversal of the sign is going to come because you've reversed the direction, the limits of the integral. This will automatically reverse the sign, as we'll see right now. When we proceed, I dot I is 1, so you get integration of e dx. E is a constant, goes out of the integration. Now integration from 2 to 1 dx, x1 minus x2. So now x1 minus x2 is a negative number, so you get minus d. D is just the distance, it's a positive number. So x1 minus x2 is the coordinate of this point minus the coordinate of this point, which means it's minus d. So that's where the negative sign comes in. So when you do this integral, you always put dr to be dxi if you're moving along the x direction only. You never put a minus sign here when you reverse the direction of the integration. The limits themselves will automatically give you this minus sign. So this is kind of a subtle point, but it's important to discuss. So this is how you would get integration from 1 to 2 e dot dr. This is how you would get integration from 2 to 1 e dot dr. You keep the dr exactly the same. It's always equal to dxi plus dyj plus dzk. for any problem. It doesn't matter the way you're going. And the minus sign will come because of the limits. Here you're going from 1 to 2, here you're going from 2 to 1. That's where the reversal of the sign will come in when you solve the problem and you proceed with the steps. You'll get the reversal in the sign. But when you write it as a limit of sums, you have to put that these delta r's are going from 1 to 2 in this case and going from 2 to 1 in this case. This is where the reversal of sign happens. In the delta r's themselves, you have to put the delta r's going from 1 to 2 here and here from 2 to 1.